Okay, let's make a start. Right, so this is the final lesson of the motion topic of P9 motion. So you would be then ready for the assessment. Okay, so this topic is mainly higher tier focused. So if you are not going to be taking higher tier, then you don't really have to worry about this section. But the main thing is being able to do some extra analysis on motion graphs. So we've talked about distance time graphs. We've done velocity time graphs as well. We've kind of looked at the difference between the two in terms of the shape that the graph makes and what you can analyze as a result from that. So first, I just want to add something additional to distance time graphs. So if you remember, we found the speed of a distance time graph to be the gradient. So the gradient, which is the slope of a distance time graph, is the speed, because speed equals distance over time. Distance divided by time is rise over run, which is just the gradient then, which is just exactly like you would calculate a slope in maths. However, previously we've done calculating the gradient for like a straight line, like a line that looks like this, like a straight line. But what if our line was curved, like in this graph here, where we have a curved line for distance over time? Well, in that case, the gradient is not going to be the same the whole time through this graph. Like, for example, the slope at this start is less steep than the slope by here. So what we work with instead when a question wants a speed from a curved distance time graph is it may ask you for something called an instantaneous speed. Basically, a speed at an instant being one particular point in time. So let's say that they would ask what was the speed at 5 seconds in. And let's say that 5 seconds in is going to be right here. That's 5 seconds. Well, here you can read the distance, but to calculate the instantaneous speed, you do what's called drawing a tangent. Basically, a tangent line, and I have an example by here, a tangent line is a line where when you have like a curve and you have one point in the curve that you want to look at, a tangent line is basically drawing another line that goes through that point. So if I were to draw a tangent for t equals 5 seconds, this will be the point. I would just draw a line that intersects that point. Now the reason why I haven't drawn my line, like I'll do another color, like here's the point. Why can't I just draw my line like this? Well, the reason why I can't draw that line that cuts through is because it wouldn't exactly fit the actual shape of the graph. The shape of the graph at that point is most similar to our blue tangent line here. So what the point of a tangent line is basically trying to figure out what is the slope at a particular point. So the key to drawing a tangent line, I'll write it down. My perfect example by here is first you need to intersect the curve or the graph. needs to cut through it. And you don't want it to be too far off the graph. You want it about even on both sides. Notice that the distance between the tangent line and this curve is about the same as on this other side. If I had my tangent line oops, that's way off there. If I had my tangent line like that, well, it wouldn't really be even on either side. Like on the left side here, it'd be way a huge, bigger space. So you want to draw a tangent line so it's about even distance between each end of the curve. So about even distance from curve on both sides of point. So remember, the point of a tangent line is to try to find the slope at a point. And if you're completely off, where you haven't really made it so that the distance from the curve is about even, then it's going to be not really a good representation of what the slope is at that point. Like for example, let's do another one. Let's draw a tangent line by do green, no, pink. Let's do a tangent line for this point. Well, if I were to just draw a line like that, that's clearly not going to be a tangent line because my pink line here, my tangent, does not really represent the slope on this point. It doesn't represent it at all. Like this slope is a lot less steep than what it actually is. You want to get it to be as close to the proper slope as possible. So you are, I mean, the point that I picked is quite straight anyway, but you are going to want to be able to accurately represent the slope. If I were to draw another one by here, that would be a tangent line. By here, that would be a tangent line. You want to accurately represent the slope as best as possible with a straight line. So just to recap, the point that you pick that you draw a tangent line for comes from the question. Like for example, when they say what is the speed at 1.5 seconds, well then you would look at 1.5 and that is the point where you draw the tangent line. So you want to actually the point that you pick is going to be from the question. So don't worry about having to choose a point because all you're doing is just reading through the question and picking that point from a graph. The hard part here is drawing a tangent line. And then if you calculate the gradient, so the rise over run of that straight line, then you would be able to get the slope at that point. So for example, on this right hand side here, this graph, I said that I want a tangent, I want to calculate the distance, the speed at point A, which is right here. So I look at point A, I draw a tangent line to the curve at point A, and then that is a straight line. Well, with straight lines, you can actually find a proper slope doing rise over run. And so I'm going to do, just to make things easier, I'm going to do rise over run with this triangle. So the rise is 2000 in this case. Oops. And the run is going to be 1 to 2.5, around 1.5 in this case. And so you just then do 2000 divided by 1.5. Let's calculate that. That's 1,333 repeating. 1333.3 recurring. And that would be your speed then. So that's what's known as an instantaneous speed, a speed at a particular point in time. That time is given to you. The hard part is just knowing to draw a tangent line, because you're not going to be able to find a slope from a curved line. Like if I just had this purple curved line here and I said find the speed, well, you'll struggle with knowing where to start, because I mean, it's curved. It's the gradient is not the same the whole way through. So the question is going to be specific and ask you to find a speed at a particular point in time. Okay, now moving on to what's known as the motion equation. So that's it for tangent lines. We'll now do what is known as the motion equation. Now for a bit of calculations practice. So in this motion topic, we've had quite a few new keywords. Well, they're not really new. They would have been things that you would have heard of before, but they're new in a sense that we now properly define them. So just as a quick recap, in this motion topic, we talked about speed and velocity. We talked about distance and displacement. And we also talked about acceleration. So those were the major keywords that we've talked about in this topic. Speed is basically just your distance traveled over time. Displacement is going to be a distance you traveled in a specific direction, so how far you are from your starting point. Velocity is your displacement over time, so it's just a speed with a direction. And acceleration being your change in velocity over time. So those are the major keywords in this motion topic. Now, all of these different concepts we've had separate equations for typically, like we have had the speed equals distance over time thing. We've had acceleration equals v minus u over t. We've had two different formulas before. Now here's the formula we're going to be working with. At first glance, it seems like quite a difficult formula. But with the FIFO method, formula, insert values, fine-tune an answer, it's not too difficult. Okay, so let me write out this formula. V squared minus u squared equals 2as. That's our formula. Okay, now I'm going to label all of these letters so you know what they mean. Let's start with v squared. Let's start with the left-hand side, v and u. If you remember from the other day when we did the acceleration formula, v minus u over t, which is a change in velocity over time, you would probably be familiar with what v and u stand for. They're both a type of velocity, but they're slightly different. In that, v is your final velocity. So at the end of the journey, what was your final speed/velocity? And velocity is measured in meters per second. U is the initial velocity. So at the start of the journey, what was the velocity? Because remember, velocity can obviously change throughout a journey. You start off from rest and then you accelerate to 30 meters per second. Well, then that means your velocity changed, your speed changed. So that is the difference between final and initial. Basically, your velocity at the end versus velocity at the start. We have two different letters for it, just to make it clear that they're going to be separate values from the question. So v squared minus u squared equals 2as. You can probably already guess what a is going to be standing for. A is going to be standing for the acceleration, which, remember, the unit is m/s squared, so meters per second squared. Now the final one, the s, this is where it might get a little bit confusing because the letter we use in this formula isn't the first letter of the actual full name. So a lot of students mistakenly think, okay, S is going to stand for speed, but it doesn't. We already have speed here, the velocities. S, and I'm sorry to say, stands for displacement in this case. And displacement is just your distance from starting point, so that's going to be measured as a distance in meters. So this is our formula. V squared minus u squared equals 2as. S being displacement. Now let's do a practice problem then. To understand how this equation is used. An object traveling with an initial velocity of 3 meters per second, I'm going to underline that because that's some information, accelerates to a final velocity of 6 meters per second. If it has an acceleration of 1 meters per second squared, what distance does it travel? So with these problems, it's basically like this formula just links our different concepts together. It links velocity, displacement, and acceleration. So as per the FIFO method, first I'm going to just make a list of what I know because that'll make it easier for me to substitute things in first. So initial velocity is u, and that is 3 meters per second. Accelerates to a final velocity of 6 meters per second, so v is 6 m/s, has an acceleration of 1 meters per second squared, so a is 1 meters per second squared. What distance does it travel? Displacement, we don't know. Now the FIFO method. Formula, insert values, fine-tune answer. So I'm going to write out my formula first. Remember, the reason why I do this is because it will allow me to substitute one by one instead of having to substitute it all in my head in one go. So I'm basically have the formula written out so then I could just replace numbers as I go along rather than combine multiple steps and give room for error. So do I have a value for v? Yes, I do. It's in my list. It's 6. Remember the squared. 6 squared minus u squared. In my list, u is 3. 6 squared minus 3 squared equals 2 times a, which is 1, times s, which is displacement, we don't know. So I've finished inserting my values now. I've written out my formula. I've inserted my values. Now I'm fine-tuning it. So this is where the proper maths comes in, where I'm rearranging for my missing variable. In this case, it's s. But I recommend before rearranging to clean up values first and combine any numbers that you can already combine. So 6 squared is 36. Minus 3 squared is 9 equals 2 times 1s, 2s. 36 minus 9 is 27 equals 2s. Now I can rearrange and it'll be a lot cleaner once I rearrange after all of this. So I want to solve for s, meaning I'm going to get rid of this 2 here by doing the opposite. This 2 is times on, so I'm going to divide by 2. Anything I do on one side, I have to do on the other. So S is overall 27 over 2, and that is going to be 13.5. So my final answer is that the object traveled a distance of 13.5 meters. Okay, I'll do one more. Find the final velocity of an object whose initial velocity is, so find the final velocity, I'm underlining that, whose initial velocity is 9, is traveling with an acceleration of 7.8, and travels for 80 meters. So final velocity, we don't know. Initial velocity, u, is 9. Acceleration is 7.8. And travels for 80 meters, so its displacement is 80. FIFO method, I write out my formula first. V squared minus u squared equals 2as. Insert my values. V, we don't know, minus u squared is 9 squared equals 2 times 7.8 times 80. Now fine-tuning it by just cleaning it up. So v squared, you can't clean that up, minus 9 squared, that's 81, equals 2 times 7.8 times 80. I can combine all of those into just one number, can't I, using a calculator? So 2 times 7.8 times 80. 1248. Okay. I want to solve for v squared, so I want to get that on its own. I'm going to be moving the 81 to the other side to get the v squared on its own. And because this is minused on, I'm going to add 81 to both sides. So those cancel. V squared equals 1248 plus 81. 1329. And I want v, not v squared. So in order to calculate for v, I'm going to square root both sides. So the square and the square root cancel on this left-hand side here. And I'm square rooting 1329. That's 36.5. Rounded meters per second. And that's my final answer. Okay. So basically we have a formula. All we do is just the same as what we have been doing with the FIFO method. Formula, insert values, fine-tune, answer. And what I want you to notice is that all physics equations use the same method, this FIFO method. You can't go wrong with it because it'll guarantee getting full marks if you go through all of it properly. Okay? Right, now just for a bit of practice, on the website we do have analyzing motion graph section with some questions. There's 10 questions up available, as well as the answers and some notes on a PowerPoint. The answers are at the end of the PowerPoint for you to practice using the motion equation. Remember to make sure that you make a list of all of the values that you know beforehand, otherwise it might get confusing because the difficult part of this motion equation is just the number of just the pure amount of letters, the pure amount of variables that are involved. So having that list becomes really, really helpful for that substitution part. Because if you substitute in the wrong numbers or you get values mixed up, that's going to be carried forward in all of your calculations. So make sure that you don't get lazy, make an actual list of all the values, write out the formula, and then substitute them in one by one. So all chance of actually making a silly mistake are gone. Okay? Right, I'm going to leave you guys to it then. Remember, you don't have to hand in this motion equation thing to me. You do have the answers at the bottom of that PowerPoint. And if you are struggling with a particular question where you're not sure where I got my answer from, just send me an email, leave me a comment on Show My Homework, and I'll be sure to get back to you. Okay, right, have a good rest of the